Okay, so let me see if this helps you. If it does, let me know, and if it doesn't, give me a call or shoot me a text, and I will send you something that makes a little more sense. So your exponent rules that you're covering in Algebra 2 that you would need to know is when you multiply two things together with the same base, so x squared times x cubed. If you were to do this out, this is x squared means x, times x cubed, which is x times x times x. If you notice, you have 1, 2, 3, 4, 5. So the shortcut, the answer is x to the fifth, is if you multiply two things together that have the same base, you keep the base and you add the exponents. So that would be a plus b. Another exponent rule you need to know is your rule for division. So like if you had x cubed divided by x squared, x cubed is x times x times x. X squared is x times x. And if we reduce, we can divide the top and bottom by a common factor. So we could divide the top by x and the bottom by x, the top by x and the bottom by x, and we'd simply be left with x. The shortcut says, if you notice, we did 3 minus 2 is x to the 1, which is just x. So the shortcut says if you've got x to the a divided by x to the b, two things that have the same base and you're dividing them, you keep the base and you subtract the exponents top minus bottom. The third exponent rule that would have been tested was when you raise a power to another power. So if you have, for example, x squared cubed, this means x squared 3 times, so x squared times x squared times x squared, or this is x times x, this is x times x, and this is x times x. So there are 1, 2, 3, 4, 5, 6. So this is x to the 6th. If you look over here, you could have multiplied 2 times 3 and get 6. So the rule says if you have x to the a raised to the power of b, if you're raising a power to a power, you keep the base and you multiply the exponents. The only other exponent rule that you might need to know, let's add a page here. Is if you have a negative exponent. So for example, if you have x to the negative 2, negative exponents are considered improper, so you put it on the other side of a fraction. Since it's a whole number, if you move it to the bottom of a fraction, it becomes positive. If you already had it on the bottom of your fraction, to make it negative, you put it on the other side of your fraction and it would become positive. The rule for that, we say x to the negative n is 1 over x to the n. So that should be kind of a review of the exponent rules, but let's go through some of the examples of questions that you need to look at for correcting your test. So the first one you sent me, let me pull it up here, was 3a squared b to the 5th times negative 2a b to the 3rd. So we can multiply anything we want in any order, and they need to have the same base. So I put my constants with my constants and my a's with my a's and my b's with my b's. So if I regroup these, this would be 3 times negative 2 times a squared times a times b to the 5th times b cubed. All I'm doing is rewriting it. There's 3, my a squared is in here, my b to the 5th is in here, negative 2 is here, I've got a to the 1 and b cubed. And I can do this because all I'm doing is multiplying, and you can multiply in any order. 2 times 3, 3 times 2, they're always equal. So now I'm going to combine my like terms. 3 times negative 2 is negative 6. I've got a squared times a. Well, if I'm multiplying two things with the same base, I keep the base and I add the exponents. 2 plus 1 is 3. These two are both b's, so b to the 5th times b to the 3rd. I keep the base and I add the exponents. 5 plus 3 is 8. So this would be my final answer. And just the more practice with these, the easier it kind of becomes. And we're just using all of our exponent rules. So number 21 had w cubed times z to the 7th, all raised to the 3rd power. So you could do this two ways. We'll do it the long way first, because you can always go back and check these the long way. All of this stuff is cubed, which means I've got w to the third times z to the seventh times itself 3 times. That's what we mean when we say cubing. So our exponent is just repeated multiplication. Since this is 3, it means I'm multiplying it together 3 times. Well, then I can multiply my w's, so w cubed times w cubed times w cubed, and multiply my z's together, z to the 7th, z to the 7th, z to the 7th. Well, when we're multiplying these things together, we keep the base and we add the exponents. 3 plus 3 is 6, plus 3 is 9. Here, when we're multiplying things together that have the same base, we keep the base and we add the exponents. 7 plus 7 plus 7 is 21. That's the long way. The short way said, hey, look, I've got this guy right here raised to a power. There's no add or subtract in the middle here of the w and the z term. So this is considered one term. So all I have to do is raise each power. So I'm taking w cubed, and this is z to the 7th cubed. And when I have a power raised to a power, I multiply. So this is w to the 3 times 3, or 9th. This is z, 7 times 3 is 21. So w to the 9th, z to the 21 power. Let's do another one here. You had a division question that said w a to the negative 3 d squared over a squared d to the negative 5th. So you can do these a couple of different ways. Negative exponents are not proper in math, so the very first thing I would do is rewrite this. So my 4 is fine, my 8 is fine, a squared on the bottom is good, d squared on the top is good, but this guy right here is a negative exponent, and so that's not okay. So I want to fix that, and this guy on the bottom has a negative exponent. That's not okay, so I need to fix that. So to take a to the negative 3rd and make it positive, I just put it on the other side of a fraction. So if he's on the top, he'll move to the bottom. D to the negative 5th, to make it positive, I just move it to the top, and he becomes positive. Nothing else changes, just the exponents that are negative. So now if I simplify this, on the top here, I've got 4. If I'm multiplying two things together with the same base, I keep the base and I add the exponents. 5 plus 2 is 7. On the bottom, I've got my 8. These two things are being multiplied together. I keep the base and add the exponents. And then I could reduce. So I can divide the top and the bottom, 4 and 8, both by the same thing. So if I divide the top by 4, divide by 4 I get 1, and divide the bottom by 4 I get 2. So I have 1 d to the 7th over 2 a to the 5th. So they're just like little puzzles. You just got to keep simplifying until you can't simplify anything anymore. So if we look at we're going to skip number 23. I'll go back to that one in a second. Number 24, 9t cubed h to the 5th times negative 2th squared. If you want to pause the video and try to work it, then come back and check your answer, then you can see how you're doing if you're doing them right. So if I'm looking at this one, I'm going to multiply. This is all of this times all of this. So I'm going to multiply my numbers together. I'm going to multiply my t's together. I'm going to multiply my h's together. 9 times negative 2 is negative 18. When I multiply two things that have the same base, I keep the base and add the exponents. When I multiply two things that have the same base, I keep the base and I add the exponents. So now if you actually want to, let's look at number 25. Maybe pause the video and check 25 and see if you're doing it right. And then if you're not, you can look at the work. So if we're working this one, notice again, there's no add or subtract in here. Since all the w's and y's are touching, we're just taking each and raising it to the power of 3. So w to the 5th cubed, y to the 4th cubed. When I have a power raised to another power, I multiply. 5 times 3 is 15, so w to the 15th. 4 times 3 is 12, so that's y to the 12th. All right, let's look at number 23 now. Number 23 is a little bit harder because you have a binomial. So you have 3r cubed, I think this says plus 5 cubed, over negative 3r squared. Oh, maybe not. I think those are t's. I thought they were pluses. So this one isn't really bad. Hold on. I think what this really says now, I was looking at I was not zooming in on it when it was on my phone. So now I can read it a little better. All right, so this is 3r cubed, t to the 5th cubed, over negative 3r squared, t squared, squared. So I'm going to clean up the top first, I'm going to clean up the bottom first, and then I can simplify. So everything in this top parenthesis is being cubed. So this is 3 cubed, r cubed, cubed, t to the 5th, cubed. On the bottom, we can do the same thing. Everything down here is squared. So this is negative 3 squared, r squared, squared, t squared, squared. So now if we go clean up the top, 3 to the 3rd means 3 times 3 times 3, which is 27. When I have a power raised to a power, I multiply, so r to the 9th. When I have a power raised to a power, I multiply, so t to the 15th. On the bottom, I have negative 3 squared, which means negative 3 times negative 3, so I have 9. Power raised to a power, I multiply, so it's r to the 4th. Power raised to a power, I multiply, that's t to the 4th. Now we've got to clean up this whole big fraction here. So I've got to clean it up. So if I look at these numbers first, 27 divided by 9 is 3, so that's a whole number that goes on top. R to the 9th divided by r to the 4th. I keep the base and I subtract. 9 minus 4 is 5. T to the 15th divided by t to the 4th. I keep the base and I subtract. 15 minus 4 is 11. There's nothing on the bottom. We've divided it all out, so this is really just 3r to the 5th, t to the 11th. Some of the other questions that you sent me, it looks like we were writing things in radical form. So exponents and radicals are the same. So for example, if I have x to the 1/2, that's the same as the square root of x. So number 29, it was 10y to the 1/2. So this is really 10 times y to the 1/2. Y to the 1/2 is just the square root of y. So it's 10 times the square root of y. So on number 30, the same concept, we have 57 raised to the 1/4. So this whole thing is being raised to a power of 1/4, or it's the 4th root of 57. And on number 31, you had 10x to the 1/3. So the 10 is not being raised to the 1/3 power. There's not any parentheses. So this is like 10 times x to the 1/3, or 10 times the cube root of x. So whatever the denominator is here is your index. Denominator is 4, index is a 4th root. And then the last two are the volume and the area problem. So we'll look at those real quick. Number 32 said, all right, we've got this rectangle. He's 6x squared y times 3xy. So the area of a rectangle is length times width. So the length is 6x squared y, and the width is 3xy. So then all we have to do is multiply those. So if you want to take a look at those and like pause the video real quick and take a look and see what you think. So if we multiply these together, 6 times 3 is 18, x squared times x is x cubed. We keep the base and we add the exponents. Y times y is y squared. Now the last one, number 33, you've got this pretty cube here. I guess he's really not a cube. And you have, let me pull, maybe he is, let's see, 3x squared, 3x squared, 3x squared. So he's length, width, and height. So volume is equal to length times width times height. It really helps me to actually write the formula. So volume is length times width times height. So this is really, again, since these are all, that's all one term. There's no add or subtract. That's all one term. That's all one term. All we're doing is multiplying these. So I can say 3 times 3 times 3, x squared times x squared times x squared. So this is 27, x squared times x squared times x squared. We keep the base and add the exponents. 246 if we are multiplying. You could have also come up here and said this is 3x squared cubed. So this is 3 cubed and x squared cubed, and you would get the same answer either way. All right, so I don't know if this helped you or not. If it helped you, great. If not, text me and I will do something else or find you something else. I hope this helps. Talk to you later. Bye.